Hi, I'm Francis Hellier, and welcome to my brand new podcast, Metaverse. This is a podcast for the future-minded, a series for anyone on the hunt for the next big thing and all its possibilities and implications. This is Tomorrow's World Today. With each episode, I will chat to those at the top of their fields, from futurists in crypto and space travel to forecasters in business and tech. Together, we will ask the question, what's next? Today, I'm joined by Apurva Shah, founder and chief executive of Duality Robotics. Founded in 2018, the company is devoted to pioneering the enterprise metaverse to solve real-world problems. Prior to this, Apurva was head of creative technology and design systems at Capital One and visual effects supervisor and member of the technical brain trust of Pixar. His film credits include Ratatouille, Shrek, Finding Nemo, and Toy Story 3. Sure you've never heard of those. He is also an adjunct professor at emerging technology at the California College of the Arts, covering topics such as metaverse design and design for trust, and is an advisor for the nonprofits Kids and Art. Fantastic to have you on the show, and such an honor to have you with us today.
Francis, thank you so much for the kind introduction, and it's just wonderful to be here with you today, and just talk about this wonderful topic.
So let's start at the very beginning with Duality Robotics. Can you tell us a little bit about the founding journey and your mission with this space?
Yeah, no. So basically, the way we got started is they say opposites attract. And so my co-founder, Mike Taylor, makes his home very much in the physical world. He's a robotics engineer, a hardcore controls engineer. Spent a bunch of his career at Caterpillar, basically building large yellow machines the size of houses. Can basically destroy things in a very physical way within a few seconds. For me, my home has always been in the virtual, as you mentioned. Some of the films that I've worked on. Most of my career was at Pixar, where I was also on the technical brain trust there. And, for a long time, we've created these, fairly extensive worlds, whether it's the Paris and Ratatouille or, the sprawling world of Cars or the underwater world of Finding Nemo. Similarly, on the visual effects side, if you go and watch a Star Wars movie today or, something from the superhero universe, I mean, most of what you're seeing is actually virtual, right? And those worlds, certainly they have a different focus. They are there to tell stories and convince us as audiences to immerse ourselves completely within those environments and those characters. So the conversation that started between Mike and me really was, what if we could take the sort of passion and creativity that goes into building a world for Pixar and combining that with the precision and the rigor it takes to build a Caterpillar machine. If you could combine those two things, then potentially there's all kinds of very, very difficult and high impact problems that, suddenly become solvable. And that is, by the way, also how we really think about the enterprise metaverse, right? So in the sort of worlds we build on the visual effects, on the feature animation side, the worlds are being built for storytelling. But the worlds that we build at Duality are there to essentially allow, machines, enterprise systems to generate data, to understand, their autonomy software, to learn about how they will behave in very different kind of situations. And so that dynamism still is very, very important.
So you're building a metaverse for solving real world problems. How are you doing that, and how are you ensuring that the behaviors are sort of predictive of the real world?
Yeah, no, fantastic question, and that's where obviously the buck stops, as it were, right? So I'll give you an example of maybe a couple of the ways that we work with customers, right? So just to ground the sort of answer in some real examples. So there was some work we did, with Honeywell Aerospace, where they were building a drone system to basically inspect energy infrastructure. Now, energy infrastructure, and here in California, that's a huge issue for us. Energy infrastructure is often aging. It's sprawled over thousands of miles, makes it particularly difficult to do predictive maintenance, right? Because where you're looking for a needle in a haystack. And so the Honeywell team had this great idea to basically use a drone fleet to start identifying potential points of failure within the infrastructure. Now, to train that system, they need lots and lots of data about both what a regular infrastructure looks like, and then also as you have anomalies in the infrastructure, whether it's rotting beams or chipped insulators or encroaching vegetation. Machine learning systems learn from this kind of synthetic data, right? And so basically, the challenge in deploying systems like that, you can build prototypes very quickly, but when you actually have to deploy the systems, you have to be able to guarantee to customers, in this case, utility companies, that, hey, we will be able to find every kind of problem that is there, potentially in a certain domain. And the problem of building the system at that point is not even building the machine learning model as much as finding, curating, and training your machine learning models with all this comprehensive data sets. And that often becomes a bottleneck, is what we found with our customers. So what we did with them is essentially built out about a 4 square kilometer place, actually, where one of the customers was operating. So it's based, again, this is why it's not a game, it's real world data. It's based on GIS data, satellite imagery, and we built them a biome that is very accurate in terms of the conditions of that particular environment. And then within that, once that environment has been built, just like we would build for Ratatouille or Finding Nemo, once we build that environment, in this case, of course, built from real world data, right? Then we can intentionally start changing it. We can start introducing anomalies into it. We can start introducing edge cases. And I'm giving you an example of a static environment in this case, but the same applies even if there were bicyclists in the environment, there were weather changes. So these environments are fully dynamic, just like our real world environments are, and can be essentially tuned and set up in lots of different conditions, right? Now, once we've built this environment, then we have a suite of sensors, so similar to what you would find on a drone system or a robotic system, and they can start generating data, right? Now, this data, of course, as you pointed out in your question, only has value if it's predictive of the real world. So we've taken, and this is again where a lot of what we're talking about is tied to the techniques we've used in entertainment before, but this is where it starts to diverge, right? So our simulator is based very much on real world physics. We give timing guarantees to our customers, right? Like, so they can expect data that has very accurate timestamps, follows real physical laws. And we've shown with every customer, because obviously the customers come with the same skepticism, right? Like, hey, is this data actually going to be meaningful for me? And so we've shown from everything from drone systems to large self-driving trucks, that what our simulator produces, the data this enterprise metaverse produces, is accurate within a few centimeters, or for machine learning models is 98, 99% predictive of what would happen with field data.
Just to clarify this, your system is powered by your digital twin simulator Falcon.
That's correct.
Can you give a little bit of insight as to the technicals around that and how the Falcon architecture works? I think for our listeners, we want to understand exactly how this works in your space, and how this has real world meaning.
Absolutely. So let me start by saying that one of our strong partners is Epic Games, which makes the Unreal Engine. So we start from there. So we use the Unreal Engine as a 3D operating system. We believe it has one of the best real-time renderers and a sort of scene management system, 3D scene management system. So we start with that foundational layer, and then what we put on top of it is sort of the entire machine models, that you might have in robotic systems. We have a whole library of sensors that can be tweaked to match real world sensors. And then one of the key elements is, unlike a game where you sort of have a fixed world, in our case, customers have very different. One customer might be doing a retail environment, another one might be doing a warehouse. One of them may be doing a flying drone, the other one might be doing basically a robotic, like a AMR, autonomous mobile robot within a warehouse. So we have to make sure that we can bring in these different definitions, whether they are for environments or machines, and what we call scenarios. Those are the initial conditions, right? That will launch the whatever data collection you want to do. So we have settled on a format called Universal Scene Description, which is an open source format that comes out of Pixar. We are working with folks across the industry spectrum, of course, including Pixar, where I still have very good relationships, to see if USD potentially should become a way to define digital twins, and HTML for the metaverse, if you will, right? Because we believe it's a very powerful way of representing 3D information, but it also goes beyond that. It can capture other physical attributes of systems. And so there's a lot of folks, right, including us, who believe that in order for customers to really get value out of this enterprise metaverse, it's very important for it to not be a walled garden, right? It needs to be something that is actually based on open standards. And that is what, we are very actively working on, through consortiums like Digital Twin Consortium.
1,000% agreed on that point. I think, again, for us to really grasp this opportunity, all of us together, decentralization and the fact that it's an open field for everyone is really important. Now, your team holds, I think it's over 50 patents across robotics and simulation and visualization, which, in itself is nothing short of amazing. So can you tell us some of those patents that you have, and again, is that restrictive to this open metaverse that we talk about?
So I'll explain the two things. So first of all, the team has got such a diverse, we are blessed, Francis, in having an amazing team that would be the envy of any tech giant. And largely the team has come around this work because we are all passionate about it, and we're all excited about it. So a lot of these patents have come out of work we have done in the past, whether it's for me, rendering and simulation work that I've done, at Pixar. Mike has done, obviously lots of control engineering work, including the first DARPA, grand challenge, which really kicked off the whole self-driving car revolution. So, these are patents that have come out of routinely the work we do. I have some patents from Capital One as well around payment systems and so on. Our approach, we've also obviously as a company, we have filed some patents as well around, this idea of the enterprise metaverse and autonomous systems, simulation for autonomous systems. But we see it largely as a defensive kind of strategy, right? We don't, for us, the patents are there to protect us, not to prevent others, if you will, right?
Agreed.
And we talked about the open source sort of paradigm before, or the open standard paradigm, right? Really to create interoperability. And I believe that for a standard to have value, it must have a backbone in some of this kind of intellectual property and an actual code that a developer can use, right? It's great to have an abstract sort of standard or a concept to strive for, but if the building blocks don't exist, then I think there's, you cannot build interoperable standards that way. And so I think, all of this sort of goes towards that, right? The generation of intellectual property, the building, the creating of these sort of building blocks for implementing a standard. And then, of course, we are also a commercial company. We want to benefit also from the work we are doing, the thought leadership we are providing. But we believe that comes from a long-term strategy, not trying to just basically say, hey, you can't use our toys because, it might maximize our return in the short term, but it's not going to help us ultimately in the long term. And, our perspective is very much the customer perspective, right? If I'm a customer who has potentially thousands of suppliers that I'm trying to source digital twins from, how am I going to do that with a single vendor or with a closed standard,
Absolutely. Now, Duality was recently selected as a provider of an advanced environmental simulation technology to help bridge the gap from virtual to real-world environments as part of DARPA. Now, please, listeners, indulge me. DARPA is the Defense Advanced Research Projects Agency, and their Race Sim program. So there's lots of to get through there. But first of all, congratulations for that. It's such an incredible achievement. Can you tell us a little bit about that and what that really means in the real world?
So it's a really interesting story, Francis, in terms of how this program came about. So first of all, DARPA is, in fact, the thought leader in terms of research, not just for defense, but for social things. Like, a lot of people don't realize that they're the agency that really launched the internet, for example, right? And again, also the self-driving car revolution came out of DARPA's sort of challenge and grand challenge in 2006, 2008 period, which my co-founder was involved with. Now the interesting thing is that the vehicles in the Grand Challenge largely they are autonomous, and most of the cars that drive on our roads today that are looking at self-driving or piloting self-driving rely heavily on maps to navigate and make sense of what they're going to do. Now, most vehicles, military vehicles don't have a road to drive on often, right? And so what DARPA wants to do with the new Racer Sim Challenge is really push that part of it forward. So yes, we kind of understand a little bit about how to create autonomy stacks for vehicles that are navigating with maps, but how do you do that when there isn't a road? When you don't know where you can drive or not drive, you have to make those very individualist decisions around going left or right or staying straight in real time, right? And that's what the Racer Sim program is trying to go after. And very much like the original Grand Challenge, they're inviting some of the best research teams across the country, universities, private industry, to sort of collaborate and participate in this challenge. Now, the first, the Grand Challenge and the challenge, the original challenge did not have a simulation track in it, because at that time, thinking was still like you build the hardware. The hardware is what is important. And then, the software obviously there's going to be some software to drive the autonomy, but really, physically building these vehicles is what matters. And I think the industry as a whole, the entire self-driving industry has realized that actually some of the biggest differentiation here is in the autonomy software, right? Like once you sense the world around you, in whatever state it is, how does the autonomous brain make sense of that information? Mm-hmm. And then how does that actually lead to, what's called actuation or real decisions around whether you're going to accelerate or steer or brake and so on? How do you figure out what is dangerous within the environment? What do you want to stay away from? When do you need to stop? So, and again, please notice how this is becoming, first it goes from being a physical problem to then becoming a sort of machine learning or autonomy problem, but eventually it becomes a data problem. Almost all of these things at scale turn into data problems, right? How do I learn? Well, I learn by being exposed to as many different conditions as possible. Now, you can try to do that in the physical world, but there are inherent limits by physical law on, how much exposure you can give a system, how much it can learn, both in terms of time, in terms of cost, in terms of logistics. You don't want to put people and teams within dangerous conditions, for example, right? And this is the benefit of bringing that learning into the enterprise metaverse, right? Once you come into the enterprise metaverse, you can, there's literally an infinite variety of learning environments, learning conditions that you can create. And so DARPA, being, they're obviously they're some of the sharpest, people out there. And so they've realized that for Racer Sim and this off-road vehicle, autonomy, they've created a simulation track from the very beginning in this challenge. And that's, that's what they've invited us to participate in. For us, success will ultimately be if these teams, the other racer teams start adopting simulation as a core methodology, for building these systems. That is ultimately what we are all after.
We've had some fantastic guests on the Metaverse podcast. And one of the questions it seems quite obvious to ask everyone is what your vision is about the metaverse, where you see this going.
Yeah. So it's interesting. The word metaverse, of course, is rooted in a very dystopian vision. And so, and I talk about this with my students at CCA, right? Like, I think technology inherently is neither good or bad, in most cases. It's what do we do with it as a society, right? Like Apple famously, I think yesterday has released some kind of a statement saying, we don't believe in, our headset will serve the metaverse. And I think that's a very narrow understanding of, what what the concept is. I think it's very important to let the concept stand on its own, independent of how the phrase was coined or its roots or where it comes from and how other companies might adopt it, right? And that's why, again, we are very careful to say that we are trying to build a metaverse for solving real world problems. For us, the permeability between the physical and the virtual is critical, right? And for us, that is where the value comes from. That's where the value for our customers come from, right? So this is not a metaverse to just immerse yourself in and hang out for hours on end, right? It's a very sort of grounded metaverse for getting real work done. And I think that people often forget that, today we do so much of our work online. I mean, if you compare it to what it was pre-COVID, and yet we have a very narrow set of tools to do that work. Metaverse can be a tool. It can be a technology that we can shape it to help people be more productive, to help this kind of very complex data generation. Now, why is this data generation critical? Well, when you look at some of the biggest problems around, let's say climate change or even building, let's say near orbit space stations, these are such sort of prohibitively complex and expensive problems that we cannot even think about how to approach them today. But of course, collectively as a humanity, we can contribute to solving these problems. But what is the mechanism for that contribution? How do we harvest this kind of human intelligence at scale? So this is part of our vision for the enterprise metaverse, is that it can be the ultimate place to collaborate and create data that is actually meaningful to our physical world and organize that information.
One of the most exciting things, I think, from when I started the podcast Metaverse was the amount of conversations I have with thought leaders and technologists, where it almost always comes back to being creative. It's about creativity and about, of course, we talk about how we can better mankind or whatever else, but ultimately it comes back to creativity, and it's really exciting to have those sort of conversations. Now, you, of all people, probably had the fortune to have on the podcast with your experience at Pixar, with Ratatouille, Shrek, Finding Nemo, Toy Story 3, all these things. Can you kind of go back a little bit and describe that story and see and kind of explain a little bit where that background will help us going forward into the future, like your personal experience from that creativity standpoint? How do you see the metaverse going forward, and what part you're going to play in that?
Now that's a really interesting, personal question that I've thought about quite a bit, right? And to me, part of what was always exciting about working at Pixar was, especially when, in those days, like with things like Shrek or Ants, even before that, which was the first film I worked on at PDI, which later became DreamWorks. There was a giant flood at the end of Ants, right? Where these ants all get washed out. And at that time, we didn't know in computer graphics how to do water, how to do fluid simulation. And I partnered with a gentleman called Nick Parker, and we were able to basically figure that out. It was more like, okay, it was not a question of, we know how to do this, great, we're just going to do it, right? It was more like we didn't know how to do it, but it was critical to telling the story, and so we better figure it out in the next 17 months and 14 days or whatever it was, right? And so I think that challenge of knowing very clearly what you're trying to do, because it's high impact, it's critical, but you don't know how to do it, right? And so for me, that has always been, as a technologist, what has driven me forward. Now, over the years, as I realized, that oftentimes we move forward on things like that without taking into consideration the second and third order effects. Now, if you're making a movie, it's not a big deal. You solve the problem, you move on. Right. I think that as we approach things like the metaverse, as we look at things that actually have more of a much longer shadow on our physical world, if you will, right? I think it's pretty important to think about, where is the compass pointing? Where are you trying to go? So from a technologist's perspective, I love the challenge of bringing the metaverse to life, because we don't know what it is today, And that's okay, but we know that once it exists, it's capable of all kinds of magic, and that's awesome, right? But also thinking about, once it is realized, where is it headed? And so I think the idea that you put forward around creativity, I think is a really important one, because I think you have to think about the human aspect of these technology systems or human technology platforms that we are creating, right? What is the second and third order effects? This is kind of why I teach at CCA and I teach designers, because I feel, when you have a table full of engineers trying to talk about a technology, they all get super excited, right? And then just move forward. And then, the business people pile on, and then, they're like, wait, what's the business side of this? And then that's great. The design voices, which often represents the customer, are missing in these early conversations. And so that's why I believe that for the metaverse, to really, again, realize its full potential, beyond interoperability and the technology actually taking form, the important thing is really what is the human angle into this? And again, for us, that human angle is in allowing the creation, allowing humans to use their inherent, their intrinsic intelligence to help create and train artificial intelligence systems. We talk about how the AI systems are black boxes. I mean, the way to solve that, I don't think there's a shortcut. I think the way to solve that problem is by having humans be much more involved in the curation of the data, the creation of the data sets from which these systems are trained. If we don't do that, we will just go in circles, right?
You touched on the CCA, so the California College of Arts, which you work as a adjunct professor. I mean, I would have been extraordinarily grateful to have you as my professor back at university. So
I don't know if my students agree.
Well, they can write in, they can send their messages to us.
That's right.
How do you cover topics like metaverse design when it's such a new area? How are you able to enunciate this? How are you able to get this across the line, if that makes sense? I mean, how are you able to add color to something that doesn't really exist at the moment?
So for the class, and I'm teaching it, with Oren Haskins, who's an art director at Google. So it's a really great pairing, because again, we have that left brain, right brain sort of pairing, in terms of for what the students receive, right? But there are 3 tracks essentially to the class, right? The first is around really giving a strong conceptual foundation. So we actually bothered to have a definition of the metaverse, which I'm happy to discuss at some point, or there's some blogs on our site that discuss it as well. But so I think starting with some well-grounded concepts, right? The second track is really around, and I think this is critical. So I think to understand any sort of complex technology, like you have to have hands-on experience. Now, obviously, these are not engineers; these are not technical, minded students necessarily. So we try very hard to create a sort of scaffolding, so that they can learn the Unreal Engine using some really great tutorials and material that Epic provides. In the case of when I teach, for example, designing for trust, like we used Google's system, AutoML system, to actually help them build machine learning models. Like, bring your data in, think about bias. So one of the things that they do is like, use essentially, I purposely give them a very biased premise and say, now go build a machine learning model to identify immigrants or something like that, right? Because it's really funny when you are so focused on solving the problem. I mean, the interesting thing is that those students come back, they build a model and they're very proud of it. And then it suddenly strikes them like, oh, when you're so focused on solving the problem, you land up doing things that you don't realize. So having that kind of hands-on experience, I think if you're going to build a metaverse, you have to be able to design a 3D space and understand what it takes to design a 3D space. And then the third track, as you pointed out, this is such a fluid area. It's still very much emerging. And so we invite amazing speakers. We had folks from Roblox and, from Epic and Google. And, so we have like thought leaders in the space come in, and they're so excited to share, because this is an audience that just wants to learn, wants to hear, right? So that's sort of how we approach the class, basically.
Amazing. So let's look at the broader scale. What are your sort of predictions for the next 10 years?
Oh boy!
Because we play this game. We play this game here. a metaverse. Like, come on,
Let's
come
see.
on.
Cool.
And if you get it right, you win £1 or win $1.
COVID 2027. I don't know. That seems to be the one thing that's a constant at this point. I think that we will be grounded. Again, I do think that we will have the virtual and the physical sort of overlapping more and more. Whether we like it or not, I think that's a reality of. Mm-hmm. So what's going to come in the future? Because I do feel like a lot of people are very nervous about that. And, I think we've talked about digital natives quite a bit. We had generations that, before, that had never used a computer. And then we have the digital natives who were kind of quite comfortable with computers and mobile phones from the get-go. I think we have a generation now, that's spending basically in the US, for example, over 50% of kids under 13 are spending some significant amount of time in Roblox, for example, every week. I mean, we are getting a generation that is similarly equally comfortable with having one leg in the virtual and one in the physical. When they think about the relationships, they have a permeability between virtual and physical relationships that honestly, as not being a, let's say, metaverse native, we simply cannot have, right? And so I think the future is very much, has the blending of these things. Then the question becomes, how do we structure it? How do we put guardrails around it to make sure that we are reaping the benefits of it without necessarily some of the negatives that we see, obviously, with isolation and with this sort of, one of the things I worry the most about is sort of the idea of subjective reality, right? So we see that with media bubbles and things like that. But now imagine that in the metaverse, which is much more immersive and much more convincing to your senses, what if I can filter even what you're receiving in real time? If there's somebody in the 3D space that doesn't, saying something you don't like, I could actually filter that and change what you're hearing in real time. Now, if you do that for two people who speak different languages, that is awesome. If you do that to prevent an exchange of ideas and concepts and sort of to, you short circuit that process, that's not so great. And here the question is also, who is the I? Who is modulating this universe, right? And what gives them the authority to do that? So these are some of the more thornier questions that I think need to get addressed. Now, the corner of the metaverse that we sit in, which is more on the enterprise side, of course, we are more focused on that permeability between the physical and the virtual. And so we have our compass is pointing very firmly in sort of what we know is going to add value. But I think if I were building a social metaverse, for example, right now, I think you need to be thinking really, really deeply about these things, and not just in terms of the technology, but in terms of the second and third order effects.
Okay, my last question: what does 2022 hold for you, Apurva, and of course, Duality Robotics? Where are you going to go? What's going to happen? How are you going to win this?
Responsibly. Number one, we're going to win it. So actually, I think what we are very excited about, we've had some amazing anchor customers that, we've started our journey with, and they validate sort of what we've built with Falcon. For us, coming, to 2022, we really, again, believe that we are sort of looking outwards more this year, where we are saying, hey, let's find a partner ecosystem. Let's look at some of these digital twin and enterprise metaverse problems for customers more from an end-to-end perspective. Whether they are product twins or environment twins or more complicated robotics twins. What does a customer want end-to-end? And again, a lot of our early work has been around designing systems and validating software stacks. We believe that the digital twins and enterprise metaverse have equal value for training, for marketing, for the entire product lifecycle. And so looking at those end-to-end value propositions for our customers is really where we are focused on for this year.
You've been listening to Metaverse with me, Francis Hellier. Thank you to my guest, Apurva Shah, for what was a fantastic conversation. I'm so grateful for your time. Tweet us at Metaverse Pod for any suggestions or feedback. And if you enjoyed the podcast, please do share a link on social media. You can sign up to receive an email when a new episode drops at our website, metaverse.fm. Thank you.